Hi, so in this video we're going to be looking at the binomial expansion. We're going to use the expression for nCr to find our coefficients. I do recommend that if you haven't watched the video on binomial expansions using Pascal's triangle, you watch that first because it will make this one easier. Okay, so the binomial expansion is given by this thing, and I do know it looks pretty hideous. It's not impossible, you just have to go steady. If you remember when we had a plus b to the power of 7, what you did is you took your a to the power of 7 and then to the power of 6. So you're taking 1 from 7, then to the power of 5, 4, 3, 2, 1, so you get a to the power of 0. And then you take your b, starting at b to the power of 0, and b to the power 1, 2, 3, 4, 5, 6, 7. And then previously we went to Pascal's triangle and then we found what the coefficients and numbers in front of our AB terms would be. But now we're not going to use that. We're going to use this thing here, this nCr thing. And the reason we do that is because it gets a bit boring writing out Pascal's triangle. So we want a quicker way of finding these coefficients. So nCr is given by this, which is n factorial over r factorial times n minus r all factorial. And factorial means 4 factorial means 4 times 3 times 2 times 1, and 3 factorial will be 3 times 2 times 1, and so forth. If you actually had 0 factorial, just by definition, that equals 1, just so you know that. Okay, so the key thing to getting this right is knowing which is n and which is r. If you look at the formula, you'll see that the n's there every time, so that's the power, and the r is the position of the coefficient in the expansion. So always starting from 0, the first one comes from 0, but then you count through 0, 1, 2, 3, and then, okay, I want the third coefficient. Now we can find this using our calculator. As I said, the key thing is knowing which is n and which is r. So if I was doing one of these, I would put 4 in first. I would find my nCr button, and on my calculator I press shift divide, and that gives me our nCr button. Then I put r in, that's the third step. So my r would be 2, I press equals, and I get out 6. And hopefully if you do all of those, you will find you get the same as you would from Pascal's triangle. Obviously you don't need this one and this one because they're always 1. Okay, so if we set a equals 1 and b equals x, our expansion becomes like this. And I hope you would agree that this is a sort of much easier looking expansion. All we're doing is going up in powers of x. We just have 1 there, so that'd be x to the 0. And then we just have to find our coefficient. So if we can have the thing we want to expand as 1 plus something, it's easier. So what I do recommend is if you have to expand something like this, you can take out a factor of a to the n, so it comes 1 plus that, and that thing there then becomes your x. And so you can work out all your different bits and then multiply it by a to the n afterwards. So sometimes that is easier, and this we're just going to practice using this expansion because it's the most useful. Okay, so if I want to find the first 3 terms of this in ascending powers of x, what do I do? So first of all, I know I'm going to need some coefficients. The first one is fine because it's always 1. Then the second one I'm going to need nC1, and my n is 5. So I'm going to put that in my calculator, and that gives me 5. And actually the first one is always the power, and then I need the second one, so I'm going to put that in my calculator, and that's going to give me 10. Now I'm only asked for 3 terms, so that's 1, 2, 3 terms. Don't go working out the whole thing if you only want, you know, some of the terms, because you're wasting too much time. Okay, then I substitute my coefficients and my x, and my x for this is going to be minus 2x into my formula. So I get 1 plus my first nCr, which is 5, times x, and my x is minus 2x, I put that in, plus my second coefficient I worked out, which is 10 times this one, times x squared, so that's minus 2x squared. And then I work it out, and I work it out in my calculator. And do remember that you must, in the calculator, put the brackets in, because when you square this, you square the minus 2 as well, but if you put minus 2x squared without the brackets, it only squares the x value and doesn't square the minus 2. Okay, I hope that's helpful. Bye.